Morning, sixth grade. Hopefully you got done with the back side on the quiz. We're ready to see how you did on the front side. Checking the ratios or proportions. Remember, you can either reduce and then figure out what you multiply by, or you can use cross products, multiply across, and then divide by what's left. I'll read the answers. If I get one wrong, circle the ones you and I disagree on. A should be 9. B should be 16. C should be 3. D should be 4. E should be 6. Next row. F should be 20. G should be 20. H should be 50. J should be 32. K should be 18. Last row. M should be 48. W should be 20. P should be 15. Q should be 45. R should be 40. Your letters would read something like this. Letter A, they asked me to multiply $41. B, multiplying by an exponent. We're going to get into today's lesson big time. Slides it right 3 times. So I get 15. C, what we just did for power up, number 6. D, estimate is 5 times 20, $100. Exponents, 2 squared is 4, 2 cubed is 8, 4 times 8 is 32. F, divide by 6 is 10, times 5 is 50. G, the mode is the one that occurs the most. You see 321 is there twice. Sum means add them together. You have to find common denominators. They would be 10. So 5 tenths plus 4 tenths is 9 tenths. 5 tenths minus 4 tenths would be 1 tenth. Multiplying, I crossed out the 2's. I'm left with 1/5. Division is stayed, changed, flipped. So I flipped the 2/5 to be 5 over 2. Multiply the top, 1 times 5 is 5, 2 times 2 is 4, 5 fourths equals 1 1/4. Problem solving. They give us the crazy words here. It says the currency of the land. In the currency of land, in other words, in this made-up kingdom, here's what money is. A guilder is worth 6 skillings, and a skilling is worth 4 ore. Vincent offered to pay Andre 10 skillings and 2 ore for the job, but Andre wanted 2 guilders. Andre wanted how much more than Vincent's offer? So guys, I just switched it to letters there, and I'm just going to show you what I did. 1 guilder is worth 6 skillings, and 1 skilling is worth 4 ore. So if I multiply these together, guys, a guilder is worth 24 ore. So 1G equals 24 ore. So this guy right here, now I'm going to do the math. 1 skilling equals 4 ore, so he's offering him 10 times 4 is 40 plus 2 more. What did he offer him? He offered him 42 ores. This guy wants 2 guilders, so I take 2 times 24, he wants 48 ores. Okay, so what's the difference? How much more does he want? I just subtract those 2. He wants 6 more ores. Or, if you wanted to convert it back, you would say, hey, you could take away and carry that to 1 skilling, so that could be 1 skilling, which is worth 4 of those, and that would give you 2 more ores left over. So one way to write it, second way to write it. Because they didn't tell us how to write it, if I was just doing this problem, I'd have left it at 6 ores. Because I did the math easy, subtract, done. This would have been another step. It didn't tell me to put it back into that term, so I wouldn't have done that without asking it. Okay, guys, so what it gets down to is I might not have ever heard of those words before, but just with mental math steps, I just multiply to get what we were after. Okay, yesterday you guys were working with rates. It's usually a multiplication or division problem. If they give me the total and they want me down to what is this per hour, it's division. If they give me what I'm making per hour and the number of hours, it's multiplication to figure out the total. Today we're moving on, working a lot with exponents and powers of 10, bouncing back and forth, division or multiplication, words, all kinds of different things that go along with it. So hopefully you have your yellow folder here with math, because you can see a lot of blanks that we need to fill in, and it goes like this. The positive numbers of 10 are easy to write. The exponent matches the number of zeros. So 10 squared is 100. You can see there's the number 2 there, you have 2 zeros. 10 cubed, 3, 10 to the 4th, 4 zeros. Observe what happens if we multiply or divide powers of 10 to find the power of a power of 10. If we multiply a power of 10, the exponent of the product equals the sum of the exponents and the factors. So what your teacher wrote, multiplying by powers of 10 is the same as sum means add, guys. Write down adding the exponents. So 10 cubed times 10 cubed is 10 to the 6. 3 plus 3 is 6. Okay? If we divide, guys, it equals the difference. So next blank, divide by the power of 10 is the same as subtracting the exponents. Number 3, if we find a power of the power, the result of the power is the product. So taking a power to a power is the same as multiplying the exponents. And then they give it to you in a little box form there, guys. So you can see a squared, a to the x power times a to the y power is just adding together. Now notice, the a's need to stay the same, guys. So I can't do 2 squared times 3 cubed and just say 2 plus 3 is 5. It's because I don't know if it's 2 or 3, guys. So it's only when the base is the same number, okay? So when you're multiplying, I add the exponents. When I'm dividing, I subtract the exponents. When I'm taking them to the power, I multiply the exponents. So here we go. We're ready for example number 1. The first one is multiplication. So as you're multiplying, you just add the exponents. 4 plus 2 is 6. In division, you subtract those exponents. 4 minus 2 is 2. In taking a power to a power, you times those exponents. So 4 times 2 is 8. It's just simplifying those things and making math a little bit easier in your thing. Okay, we're ready to pause to get extra credit on your worksheet, guys. Mr. Bauer switched colors today. So you write down the color of the marker I use on the top of your fact practice. For bonus, you can write down the color I used yesterday. I'll be really impressed if you can remember the color of the marker I used yesterday. In between example 1 and example 2, it says this. We can use power of 10 to show the place value as you see in the chart. Notice that 10 to the 0 power equals 1. Later on this year, you're going to learn that any number to the 0 power is 1. But we're not there yet, guys. And so we're going to do expanded notation, guys, this time using exponent. So all I do is count the number of places after the number, and that's the exponent I use. So they give me 5,206. They say write this using powers of 10. So it looks like this. I start with the number 5 times 10, and I go how many numbers are after it? 1, 2, 3 to the 3rd power. Parentheses, add. I write the next number, 2. How many numbers are after it? 1, 2. So it's times 10 to the 2nd. Remember, we don't need to use 0, so it's gone. Next one, adding in between. Next one is 6. How many numbers are after it? 0. So it's times 10 to the 0 power. In parentheses, adding in between there, expanded notation. Okay? So it's just switching to exponents. Feel free to use your chart that comes with that, like the one in the book, but it's pretty simple. Just count the numbers that are after it. Turning the page, it says when we multiply a decimal number to the power of 10, the answer has the same digits in the same order, only the place value is changed. When I multiply, I'm sliding to the right. So guys, back into your notes, it just simply looks like this. Multiplying by powers, number of times to the right. Therefore, dividing by powers, number of times to the left. So I got the power of 2 here. That means 2 to the right. 1, 2, rewrite. 4, 6, 2, 3, that's where my decimal point goes, 5. All the numbers stay the same, guys. I'm just sliding to the right. I might have to add zeros if we need to. Next one says, sometimes the power of 10 are written with words instead of digits. For example, we might read that 1.5 million spectators lined the parade route. The expression 1.5 literally means 1.5 times a million. So can I write 2.5 billion in standard notation? Well, guys, remember, billion is 9. So instead of saying half, I just write 2.5, and I need 9 of those, so it's literally 2.5, and then slide it to the right 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The 2 is in the billions position. The 5 comes after it, 500 million. So I don't know what's easier for you to remember at times and do this like this problem up here. Number of exponents is the number of times, and just switch this to 2.5. Billion means 9, so I slide it right 9 times. I like to do that. So I would say this is 2.5. I'm going right 9 times. I know I have to get behind one number, which means there's 8 more zeros. So I just do 9 minus 1 in my head to get the answer. Switch it around. When we divide by the powers of 10, the quotient is the same digits as the dividend, only the smaller place value. As with multiplication, we may shift place values by shifting location of the decimal point. To divide a number by a positive power of 10, we shift the decimal point to the left. of the place value indicated. So you see the bold there, guys. The bold in example 3 gave you that helpful hint. So here I'm going left 4 times. I know I have to get in front of one number, so I have to add 3 zeros. 1, 2, 3, then 3, 5. Okay? Numbers stay the same. You just slide those things. You decide if you're going to count or if you can go 1, 2, 3, 4, and then you put in the zeros where you have your little squiggly lines going across there. Okay? So divide, smaller. Multiply, bigger. When I'm multiplying, I add the exponents. When I'm dividing, I subtract them. If I'm taking a power to a power, I'll multiply those. Keep those in mind. We're going to build on those as we go through the year and use those more and more. Okay? We'll see you for the problems. 6, here we go with number 1. It says twice as many students walk to school as ride to school. Is that true or false? Well, if I look at the walks is 10 students. Ride in a car is 5 students. Yep, that's true. So A would be true. B says the majority of students ride to school either on a bus or a car. So I go to rides on a bus, it's 12. That gives me a total of 17. Walk or ride a bike is 10 plus 6. That's 16. So is this a majority? Yes, it's more than half. So that would also be true. Number 5. Write this number in standard form, guys. That's today's lesson. So I have millions is write 6 times. So 1, 3, 4. Then write once, twice, 3 times, 4, 5, 6 times. Go back and put commas. Guys, if you notice, that comma goes right where that decimal point is. So anytime you have the words millions or billions or trillions and you have a decimal like this one, 134.8, the comma goes where that decimal is. This would be viewers. Number 7. A gallon is 128 ounces. In the 12-ounce glasses, how many glasses are full? So that's yesterday's. Can we work with rates and just divide those things? I have 128. I'm going to divide it by 12. Goes in there once. That's 12. Subtract 0. Bring down the 8. 12 goes into 8 0 times. So A, how many glasses are full? 10 glasses are full. B says, how many glasses are needed to hold all the water? That's 11 glasses. I need one more glass, guys, to hold this 8 ounces. What they're asking you in that question is, did you know that this is just 8 more ounces and you only need one more glass? Or did you think the remainder 8 should have been added and you have 18? So I just need one more glass. Down to number 11, it says round to the nearest thousandth and number 1,000. So if I'm writing these things, guys, I have 53,714.5454. Okay, first one says round to the nearest thousandth. That's here. I look here. It doesn't do anything. So everything just stays the same. 714.545. B says round to the nearest 1,000. That's here. Look here. That goes up. So 54. Everything after that turns to 0. I don't need my decimal points, so I'm done. Here's A. Here's B. Number 14. I have a figure, and it says this. In the figure, all the angles are right. AF is the same as AB, which is the same as BC. BC is twice as long as CD, and CD is 3. So this is 3, which is twice as long as BC. BC would be 6. In my equal signs, BC was the same as AB, which would make that 6, which is the same as AF on the top, which would be 6. Now they ask me for perimeter, guys. So step 1, I need to figure out the left side. It's the same as the right side. 6 plus 3 is 9. The bottom is the same as my top horizontal numbers. 6 plus 6 is 12. Now it's just addition. 9 and 12 is 21, 24, 30, 36, 42. So I have 42 centimeters. Number 15. Use a compass to draw a circle that has a radius of 1. So I draw a circle. It has a radius of 1. Then inscribe a regular hexagon. Remember the hexagon, 6 sides, guys? It's like a clock. 12 o'clock, 2 o'clock, 4 o'clock, 6 o'clock, 8 o'clock, 10 o'clock. We did this a long time ago in Investigation 2. Connect my dots, so I inscribe my hexagon. A says, what's the diameter? Well, if the radius is 1, the diameter is 2 inches. B says, what's the perimeter of the hexagon? These are all 1 inches, guys, and you have 6 of them, so that's 6 inches. Turning my answer key over, I have number 17.
17 has 3.6 is to x as 16 is to 24. I'm going to divide by 8s here, guys, to reduce this. So this is 2/3. Now I'm going to say, how did I get from 2 to 36? That's times 18. 3 times 18 is 54, but I wasn't 36. I was 3.6, so I'm not 54. I'm 5.4. So I always like to reduce these guys and work with something I can see. Your other choice is cross multiplication. 3.6 times 3 divided by 2, or 3.6 times 24 divided by 16. Big numbers, sometimes it's easier to reduce and work with smaller numbers. 20 and 21, it says estimate and then solve actually. So if I just look at those problems, guys, 4 plus 5 plus 1 gives me 10. That's my estimate. Now I'm going to go for real. I have 4 and 1/5 plus 5 and 1/3 plus 1/2. Those are equal to 30s. So this was times 6 over 6, which would give me 6/30. This was times 10 over 10, which would give me 10/30. This is times 15 over 15, which would give me 15/30. Add 16 plus 15 is 31/30. That equals 1 and 1/30. Take my 1, add it to the 4 and the 5, gives me 10 and 1/30. My estimate, my actual, very, very close. 21, I have 6 minus 5 minus 2 as an estimate. Parentheses say do it first, that's 3. 6 minus 3 equals 3. There's my estimate. Actual says do 5 minus 1 and 2/3. Cross out the 5, make it a 4, bring over 3/3. 3/3 minus 2/3 is 1/3. 4 minus 1 is 3. Now I'm going to take 6 and 1/8 minus 3 and 1/3. Common denominators are 24. That was times 3 over 3 to give me 3/24. This was times 8 over 8, which gives me 8/24. Can't do that subtraction. Cross out the 6, make it a 5. I'm bringing over a 24. I'm adding it to the 3 is a 27. 27 minus an 8 is 19. 24 stay the same. 5 minus 3 is 2. Boom. I got a 2 and 19/24. Number 22. The easiest way to do this one, guys, is to take it apart. Square root of 16 times the square root of 25. Square root of 16 is 4. Square root of 25 is 5. 4 times 5 is 20. Your other choice is you could have multiplied 16 times 25 together, got 400. The square root of 400 is still 20. 24. I'm going to make them improper as we cruise along here. 8 and 1/3 is 24, plus 1 is 25 over 3. 5 times 3 is 15, plus 3 is 18 over 5, and 1/3. So 5 goes into 25 5 times, 3 goes into 18 6 times, 3 goes into 6 twice. On the top, 2 times 5 is 10. 26. Big addition problem, guys, with decimals. Remember just to line up your decimal points. 26 and 7/10, 3 and 45/100, 0 and 36 thousandths, 12 and nothing, and 8 and 7/10. Feel free to add zeros in, guys. I'm not going to. 6 and nothing is 6. 5 and 3 is 8. 7 and 4 is 11, plus 7 more is 18. Carry the 1. 1 and 6 is 7, and 3 is 10. 12, 20. Add a 0. 2, 2, 1 is 5. Decimal was straight down. 50 and 886 thousandths. 27. You got these triangles. They're the same triangle, just rotated, guys. So I'm just going to draw my 3 triangles and say if I want the perimeter for A, I need the things that are on the solid line. Well, in figure 1, that's a solid line, that's a solid line, and that's a solid line. So I'm just adding those together for A. 5 plus 3 is 8, plus 4 is 12. Carry the 1. 1 plus 1 plus 1 plus 1 is 4. So I have 42 inches. Now, guys, to figure out the area, all the areas are the same. So you pick whichever one you want to work with. I want to work with two whole numbers. So I'm picking this triangle because it's two whole numbers. Base times height divided by 2, guys. I'm going to take my 14. I'm going to divide my 12 in half in my head and just multiply. 24, carry the 2, it's 8. So B would be 84 inches squared. That's a great problem, guys, to get you to say it's the same triangle spun different ways. Don't figure out area off of that one or that one. We don't want to work with mixed numbers. It's just more work. Okay, that was 27. We're cruising on to 29. It says arrange these numbers in order from least to greatest. So I have 2/3, 1/2, 7/12, and 5/6. 12 is the common denominator, guys. That's 8/12. That's 6/12. That's obviously 7/12. And that's 10/12. Now I'm just going to put them in order. 6/12 is the smallest, but I write it with the fraction they gave me. So it goes back to this 1/2. 7/12 is next. 8/12 is after that, but it goes up to the 2/3. And 10/12 is the final one, but it goes to the 5/6. So you must find common denominators when you're working with fractions and putting them in order. And last but not least, I have 130, A, B, C, and a 65. A says find A. It's on a supplementary line, guys. They add up to 180. So to find A, I do 180 minus 130. That gives me 50. A equals 50 degrees. B is inside a triangle. 50 plus 65 is 115. Triangles add up to 180. So I got 180 minus 115 is 65. B is 65. C says, describe how to find the measure of C. Now, how do I find C, guys? It's a straight thing. So I would do 180 minus whatever B is. Now, we know what B is, guys, but I don't have to do the math for that. It just says describe how you do it. D says name supplementary angles. Supplementary angles are things that form straight lines. So choice 1 is this angle, angle B plus angle C. Choice 2 is this angle, angle A plus 130. They didn't say name 2, so either one of those would work, guys. Both of them is super awesome. Awesome. Done with lesson 47. Have a great day.